Hi there and welcome back. Let us look at this example over here. We are told that a strain of mold was given in a batch culture on glucose and the following data was provided. We are given the experimental time, the concentration per time, and also the glucose concentration per time. We are requested to calculate the maximum net specific growth rate. To calculate the apparent growth yield, point number C asks what maximum cell concentration could one expect if only 150 grams of glucose were used with the same size in a column. And then lastly, the doubling factor. Okay, let's define each variable. In this scenario, X, it's the cell concentration. U alone, it's the specific growth rate. U max, it's the maximum growth rate. U net, it's the net growth rate. Y subscript XX, in this scenario, it represents our apparent growth yield. S being our substrate and TD being our doubling time. If we were to plot a graph of our cell concentration X versus time in hours, we would expect a growth curve like this. This is just a typical growth curve example. If you were to plot one, you should expect something similar. This figure example here just shows you the different phases of the growth rate per time. Calculate the maximum net specific growth rate. To obtain this, we are going to say ln x2 minus ln x1 over time t2 and subtracting time t1. If you punch in your values there, you should get an answer roughly amounting to 0.099 per hour. Secondly, let us calculate our apparent yield. To do this for subscript x over s, we are going to say the change of x versus the change of s. In this scenario, x, it's our cell concentration, and s, it's our substrate, in this case, the glucose. If you punch in all the values there, you should get an answer of 0.4 grams cell per grams substrate. To answer for C, the maximum cell concentration, we are going to say the initial cell at time 0 plus the apparent yield multiplied by the initial substrate. In this case, we are given 150 grams. Punch in everything there and you should get 61.25 grams cell per liter. Lastly, let's get the doubling time. We can assume that our U net will equals to our U max, and we know that the U max is equals to ln 2 over the doubling time. Rearrange everything and make doubling time the subject of the formula. Punch in all your values and you should get an answer roughly estimating to 7 hours. Okay, now thank you so much for watching. I really hope this do make sense. Till next time, bye.